All righty, friends. So we got our third and final video on trig graphs and what we're looking at here. So the last two functions we got to deal with are tangent and cotangent. You can kind of see them right here. Now, some of the teachers here at Whitney, they'll teach you to rip and flip tangent to get to cotangent. I don't. I think it's, for me, I think it doesn't make much sense to. I mean, I understand why they do it, but I think it's better that if we just learn a couple more values. So we're going to have a couple more tables that we have to use. So tangent and cotangent, they have their own starting values. Now, if you notice, though, there's a couple interesting things about tangent and cotangent. If you notice, the period length is only pi. I just realized that it had period down below there. Oopsies. So the period length is equal to pi. However, pi is also the distance, that period length is also the distance between the asymptotes. So one period only exists between the asymptote. My handwriting is not good. That's what I get for writing with the mouse. All right. So we got some different starting values, and we have the period length. So the first time our period length is no longer 2 pi divided by b. Our period length is really going to be pi divided by b, or pi divided by the absolute value of b. Okay, so that's our period length. Also, there's some other things that are kind of cool about that make these just a little bit easier as well. With tangent and cotangent, there is still no amplitude because it goes from negative infinity to positive infinity. Likewise, there are no relative maximums and no relative minimums, because again, they stretch from negative infinity to positive infinity. Now, also, when we're looking at the graph, as far as determining if it's even, odd, or neither, a tangent function or a cotangent function can never be even. Because, again, remember, graphically, for our trig functions to be even, they have to have a relative extrema on the y-axis. And since tangent and cotangent don't have relative extrema, they'll never be even. However, there are a couple times when it can be odd. We have to deal with this a little bit. So a tangent or cotangent function could be odd if, the first thing is if, see if I can change the color there we go. If an asymptote is on the y-axis, or if the inflection point, and actually in calculus we call this point of inflection, not inflection point, is on the y-axis. So that inflection point, that's where the graph goes from opening down to opening up. So let's see here. That inflection point is right there. If an inflection point is on the y-axis for tangent or cotangent, then it will also be odd. So it could be odd for a couple things, but the nice thing is for tangent and cotangent, can't be even. Never will be even. So what we're going to do here this last little bit is we're going to just graph some tangent and cotangent graphs, and then we will be done with our trig graphs. All right, so let's take a look at one here. And I'm going to change one of these real quick, if you don't mind, friends. I'm going to change. That's not the color I wanted, friends. I wanted this to be white. We're going to change this one. So on your notes, do me a favor and change this one to be y equals cotangent of 1/2 x plus pi. We're just adding a 1/2 in there. That wasn't there before, just so we can get a chance to see something a little bit different. All right, and here's what I'm going to ask that you guys do. We're not going to do that vertical transformation. We're going to keep it in terms of vertical reflections. So we're going to find the amplitude. If it's there, you know that it's not. The vertical reflection. We'll find the period length. We'll find the phase shift. We'll find the vertical shift. We will find the domain. We will find the range. And then we will determine if it's even, odd, or neither. And we can just go ahead and just, since it's tangent, we could just toss out even, because we know that can't happen. All right, so again, you should be getting used to this by now. All of our trig graphs, they still follow our transformation idea. So A times tangent B x minus c plus d. So I don't have a b value on this first one, which is kind of nice. So I have a, which is 2, b, which is 1, c, which is pi, and d, which is 1. So again, I can deal with a lot of stuff just by this right here. Amplitude, well, like we all know, friends, there is no amplitude for tangent. Vertical reflection, and again, that question is a negative. Is a negative, and you would say, no, it is not. Now, if I ask for the vertical transformation like it said up here in the directions, that would just be vertically stretched by that a. So vertically stretched by a factor. And that's all that's saying. Period shift. So our pi is going to be divided by the absolute value of b. So pi, our b value is 1. So divided by the absolute value of 1, well, that's still just pi. Our phase shift is still c, and our vertical shift is still d. So let's see, our c value was pi, so we're going to go right pi. And our vertical shift, our d value was plus 1, so we're going to go up 1. So now for tangent and for cotangent, we always go from one asymptote to another. So for tangent, and I don't know if you guys paid attention to those values when we were there, we started at negative pi over 2, and that was an asymptote. So because it's an asymptote, we'll just put undefined. So nothing is going to happen at pi over 2, negative pi over 2. It's just going to be an asymptote. Well, I probably don't need to write that twice. There we go. Negative pi over 4 is negative 1. 0 is 0. So both tangent and cotangent, they just had different values that we're starting with. Pi over 4 is 1, and pi over 2 is undefined. But everything else is still the same. Nothing is going to change. We still are graphing it the exact same way. So we're still going x divided by b plus c. Still going y times a plus d. So we're still using our transformations to graph these things. So our b value here, I didn't have one, so that's just x divided by 1 plus my c value, and my c value was positive pi. So x plus 1 plus pi. Y equals a, so, or y times a, so y times 2 plus d, so plus 1. So these are going to be the values that we're going to be playing with here. So negative pi over 2 plus pi, that would be a positive pi over, oops, That'd be a positive pi over 2. And then undefined times 2 is still undefined plus 1. So that never changed. That's still undefined. Negative pi over 4 plus pi, that would be 3 pi over 4. So negative 1 times 2 is negative 2, plus 1 is negative 1. That didn't change either. Now we're at pi. 0 times 2 is 0, plus 1 is 1. Pi over 4, that would be, plus pi, that'd be 5 pi over 4. And 1 times 2 is 2, plus 1 is 3. And pi over 2 divided by 1 is pi over 2, plus pi, that'd be 3 pi over 2. And then the undefined is still undefined. That is still an asymptote. So we get our values. So we got our table now. And again, just like before, we always count by the smallest or the largest denominator. So we're going to count by pi over 4s. So let's see here. 1 pi over 4, 2 pi over 4, well, that's pi over 2. 3 pi over 4, 4 pi over 4, 5 pi over 4, 6 pi over 4, that's 3 pi over 2. Just for the fun of it, I'm going to put a negative 1 over here. So this is negative pi over 4. So this right here then is 2 pi over 4. And this is 6 pi over 4. So that's what I'm counting towards. All right, so I have my asymptotes in at pi over 2. And there we go. So there's my asymptotes. We're going to throw our points out there then. 3 pi over 4, negative 1. Pi is positive 1. 5 pi over 4 is positive 3. I'm going to go ahead and graph off my point of inflection. So I'm going to start from that point of inflection. Then go down. Can I now make it open up from my point of inflection to go up? So there's my graph. Now, remember that this thing is going to potentially be so in order for it to be odd, that graph is going to have to either have an asymptote on the y-axis, or it has to have that inflection point at 0, 0. So is the asymptote on the y-axis, or is the inflection point at 0, 0? So asymptote. So again, for odd, I'm looking for one of two things. Is my asymptote on the y-axis? I know it can't be neither, or even, I mean. Or I'm looking for, is that inflection point, that point of inflection, is that at 0, 0? Is the inflection point at the origin? So the inflection point is on the y-axis, so it's close, but it's not quite at 0, 0. So this is going to be neither. So it didn't quite get there. It got close. And the range, well, that's going to be all real numbers. I can see when I graph that other one that I'm going to have a y-intercept at 1, but let's just prove that just to make sure we can. So the y-intercept, this is going to be when x is 0, so 2 times the tangent of 0 minus pi plus 1. So 2 times the tangent of negative pi. So that's the same thing as positive pi, and tangent of pi is 0 because the y value is 0. So we have 2 times 0 plus 1. So the y-intercept is actually out 1. So you got really close to having to be an odd, but it didn't quite get there. I need that y-intercept to be at 0, 0. All right. And let's see my asymptotes. So my asymptote, where's my first one at? It's at pi over 2. So pi over 2 plus my period length, which is pi. So that means my domain can be any value but the asymptote. So x can't be equal to pi over 2 plus pi n. And then one of my favorite parts about tangent is when I'm dealing with my relative extrema. Relative maximum doesn't have one. Relative minimum doesn't have one. All righty, friends. Well, why don't you guys go ahead and pause the video and see if you can't try the cotangent one. Again, remember our different values that we have for cotangent. Try cotangent and see what you guys come up with. In case you forgot what those cotangent values were, let me write them up here real quick, so that way you can keep this one up here and have it as an example. So for cotangent, it started at 0 and it was undefined. Pi over 4 was 1. Pi over 2 would be 0. 3 pi over 4 is negative 1. And pi is undefined. All right, friends, why don't you go ahead and pause the video and see if you can do that cotangent one at the bottom. I gotta erase that one again real quickly. Let's see how you guys did on this. Oh, what did I have up there? I had y equals cotangent of 1/2 x plus pi minus 1. That was one I gave you. All right. So again, just like with every other trig function, they are all transformations. So a times, cotangent. Now I can put my b, x minus c plus d. So if I come back here and I'm looking at this, I needed to factor out my 1/2. So there's nothing in front of there, so we have 1 in front. So 1 times cotangent, got to factor out a 1/2 there. X plus 2 pi minus 1. So we have a, which is 1, b, which is 1/2, c, which is negative 2 pi, and d, which is negative 1. And then we can go through and write all the stuff that we have to find again. Oh, my personal favorite, amplitude, vertical reflection, period, phase shift, vertical shift, domain, range, and then even odd, or neither. And again, remember, there is no even on these. It can only be odd. And how can it be odd? It meets one of two different qualities. First of all, if it has an asymptote on the y-axis. Or if it has the point of inflection at 0, 0. So let's see if we have those two things. All right, first let's head on through here. Amplitude, again, friends, there is no amplitude, just like there'll be no relative extrema. Vertical reflection, in other words, is a, you guys are probably getting tired of me writing the same things there, is a negative, and you'd say, no, it is not. Period. Pi divided by the absolute value of b. So pi divided by, what's our b value? It's 1/2. So pi divided by 1/2. So the period for this one's going to be 2 pi. I have a little different period. Phase shift, I'm going, that's my c value. My vertical shift is my b value. So I'm going to go left 2 pi. And my vertical shift, I'm going to go down 1. So my values for cotangent, 0 and undefined. Pi over 4 and 1. Pi over 2 and 0. 3 pi over 4 and -1. And I almost put 2 pi there. Pi and undefined. And then the last time I'll have to write this for a while. To do our transformations, x divided by b plus c and y times a plus d. So our b value, we have x divided by, our b value is 1/2. And we're going to add -2 pi to it. So in other words, this is going to be 2x minus 2 pi. Our our a value is 1, so y times 1. And then I'm going to subtract 1 from it, so plus a -1. So y minus 1. So those are going to be the values, or that's going to be our transformation rules that we're going to follow here. So 0 times 2 is 0 minus 2 pi, -2 pi. Pi over 4 times 2 is pi over 2, minus 2 pi is -3 pi over 2. Pi over 2 times 2 is pi, minus 2 pi is -pi. -pi over 2, and 0. We plug in our undefined minus 1 is still undefined. 1 minus 1 is 0. 0 minus 1 is -1. And then we have -2. And look at it this time. 0 is undefined. I'm going to have an asymptote on the y-axis, which means that this is actually going to be an odd function. No, we're not quite to that yet. We got to graph it first. And again, we are going to count by, when we do our asymptote, we're counting by the largest denominator. So we're counting by pi over 2s. So that means this one right here is going to be negative 4 pi over 2, which is the same thing as negative 2 pi. That's pi over 2. Always, always, always label your axes. Got to have the axes labeled. All right. So we'll graph our asymptotes. And we'll graph our points in there. Negative 3 pi over 2 is 0. Pi negative 1. And we have here, from the point of inflection, we're going to graph our graph out. So it opens up and it opens down. Later on, we'll call that concavity. So concavity is how it opens. The domain, all real numbers. We have an asymptote on the y-axis, so this is going to be odd. The y-intercept, well, friends, if I have an asymptote on the y-axis, that means there is no y-intercept. My asymptote, and again, probably should use the one on the y-axis, but for whatever reason, I always go with the one furthest left. My own little pet peeve, I don't know why. So negative 2 pi plus whatever my period length is, 2 pi n. And so since that's what my asymptote is, my domain, my x's can't be that. So x can't be equal to negative 2 pi plus 2 pi n. And last and certainly least, friends, what are the relative extrema? Well, because it goes from negative infinity to positive infinity, relative minimum, there will be none. Relative maximum, there won't be any. And friends, that is the cotangent graph. All righty, so we'll talk more in class tomorrow about all these other trig graphs that we looked at, and we'll have a little fun playing with them. All right, have a good evening.